we have the wonderful Dr. Gina Paghetti joining us today to lead our discussion on the milk battle. So it's supposed to be a fact-based discussion comparing both of these guys against each other and hopefully demystifying some of the misinformation that may be out there and sharing some information that maybe you don't know about either one of them. And I'm sure Gina's going to tell you a little bit more about herself and her background, but you can kind of see what she does on the bottom. So she is all about dairy, all about immunology, and all about mastitis. So she works in this world quite a bit, not so much from a consumption side, but more from understanding immunology, understanding immunity, and really looking at both sides of the equation. So with that, I'm going to let Gina take it away.
All right, cool. Thank you. Thank you for the invite. Say a topic I enjoy talking about. So if you have any questions as we go through, please feel free to put it up in the chat. I'm getting pretty good at monitoring while I'm going through classes during this semester. So please feel free. As far as a little bit about myself, I think I know quite a few of you, but some I don't recognize names. But I grew up on a small dairy farm up in central Pennsylvania. Say we 35 to 50 cows. Went to school at Penn State, where I did a dairy science degree with a business minor. And really, I went home for about 3 to 4 months, maybe 6 months. I realized Dad and I are on totally different pages in terms of where we wanted our home dairy to go. He was content and I wanted to push some barriers, and so it wasn't a good combination. Luckily, I went to did research when I was an undergrad and found out I really enjoyed science and ended up going to graduate school at Penn State looking at basically mastitis and the immune system of dairy cows, which is what I still do today. And I enjoy kind of all sides. I love going out and working with farmers. I love working in the lab and figuring out why things work the way they do. So it's a big part of me. All right. And for those students out there, I was a first-gen student. I was the first one in my family to go to school, and I made it the whole way through a PhD. So which one should I choose? I say the battle today is raw milk versus whole milk, and what are the differences? What do they look like? I will say I grew up on this. This is exactly what our jug looked like. I say we had a gallon jar because there was 5 kids, and we pull it straight from the bulk tank in the morning. And I'd say we'd have the cream line. So to this day, I still shake my jug because it's just habit at this point in time to do that. And I drink a lot of milk still, and Weigel's is one of my go-tos because it is local milk. And it has this nice, light, safe yellow jug that protects it from being oxidized from the light. So, and say it does support our local farmers. So looking at the comparisons between raw and pasteurized based milk. So what are some of my goals for today? What are some of the risks associated with foodborne illness, primarily from raw milk? So we'll go through that. Some of the health comparisons of raw and pasteurized milk, and probably some you're not aware of, because I kind of got into how it impacts the immune system. And so pulling out some of that kind of newer research and where it's going. And then the very last bit will be state regulations are highly variable. And so there is access to a website. We can kind of go in and look at the different rules for different states and what may be going on. But like I said, feel free to ask questions as we go along. All right, so I know you all talked about processing and pasteurization in the last session, so I'm not going to focus so much on that part, but why we do it for health-based reasons. And really, it all boils down to killing foodborne pathogens, killing those bugs that make us really, really sick, to lower that risk. And so these are just some snippets from Food Safety News, which follows a lot of these a lot of these outbreaks, and from not just from milk, but from other sources as well. And so usually really good, unbiased type of information of what the issues are and what the findings were. So I tend to use those for my news outlet for these. And so we have from raw milk, I say here in Knoxville back in 2013, which was an E. coli base with 9 children. I say E. coli is common. You'll see that in a couple of different scenarios. In New York, they've found another common organism, which is listeria. This one can cause a lot of complications, even especially for pregnant women, and complications with their pregnancy that are in place. So one that's definitely a challenge for multiple people. And then Campylobacter seems to be the most common one that we isolate out there. And it's a type of organism that does also cause a lot of gastrointestinal upset. We're going to put it mildly. And then in France, I say there was another outbreak, tied to salmonella. So these outbreaks do happen across the world, and the organisms that cause the challenges are pretty similar in those. And these bugs, the reason they cause a problem is they do like to get into your GI tract, and because of the food sources that they have there, they multiply rapidly and cause a huge immune response. And it's that immune response which is helping drive a lot of those clinical signs that we see in terms of diarrhea and vomiting and fever, all of those issues that come into play. And in the young and the very old, we can run into some extra challenges with that. And so this is the biggest reason why we pasteurize, for health-based reasons. Now, it's got some extra added benefits that are out there too, but we're going to focus on the health side today. All right. So because those organisms are such a challenge, we really do try and control them the best that we can, but it's not foolproof. And so I know Dr. Eckelkamp went through a lot of these two master dairies ago, how we can control minimizing the introduction of foodborne pathogens while we're on the farm. Same is going to be true in that processing center, because it's kind of like garbage in, garbage out. So if we start poor, we're not going to get any better. So we need to start clean, need to start with the minimal risk, and then maintain that throughout the system. Same holds true for the consumer. Say how we store that milk has a difference and makes an impact on that process. And say one of the things I did not have in this today is just how we store raw milk versus pasteurized milk, because raw milk doesn't last quite as long as pasteurized does. And we'll get into those reasons here in a bit. So what are some of those risks? So in 2012, the CDC went and compiled a bunch of data from 1993 through 2006 and used that to kind of estimate how much raw outbreaks were coming from non-pasteurized or raw milk versus pasteurized milk products. So this gets into the total number of outbreaks. So fluid milk as a whole, 46 versus only 10 outbreaks for pasteurized milk. So definitely almost 5-fold difference in terms of those number of outbreaks. And cheese, let's say a little bit different. There's slightly more cheese outbreaks for the pasteurized milk, but more people eat that. So we expect more to happen. But when we kind of break this down in terms of our outbreaks and who's the dominant driver, it's going to be that raw milk, which runs about 60%, versus pasteurized, which runs about 40% of our outbreaks out there right now. So that 4.5-fold difference. greater risk. When we look at who's getting sick, so this is all illnesses, doesn't matter how severe it is, most of these are actually mild, but we have, say more people that are overall impacted by pasteurized milk. So more people do get illnesses from pasteurized milk, but got to keep in mind how many people are drinking pasteurized milk versus raw milk. Huge difference in terms of the number of people that have the potential to get sick. And so when we put it on that basis, the risk of raw milk is higher because we have fewer people drinking that product, but almost half as many infections. And so it really is a big part of that process. And what we've realized is that many of these are young people, less than 20 years old. And a lot of times these are really young children, 7, 8, 9, 10, 12, 14 years old. And so they're the ones that are getting the sickest when we start looking at hospitalizations, those that really develop severe infections. So when we break that down, raw milk is accounting for about 85%. So these are the ones that severe diarrhea, severe vomiting, high fever, start to get dehydrated and have complications in their body systems that can lead into major complications and death. And so those are the ones that are a bigger challenge. Whoops. All right. So, and let's just kind of summarize those key points. So the CDC did go out and look at a more recent data set. Still not great. Goes from 2006 up through 2012. And during that time frame, they have logged in 81 outbreaks from raw milk, which is almost double from what they've had in those prior 12 years. It averages out to about 13.5 outbreaks per year, 26 states, 980 people that are ill, about 10% get hospitalized, 8%. And Campylobacter seems to be the big driver of most of our infections. So it is there. And what they don't know is that estimate of how many people are impacted that didn't go to the doctor, didn't go in and get checked. So we think we're underestimating that value that's in place. And say, once again, just kind of noticing it's the young people. So this is the percent of illnesses. These are the number of people, or the age group, 1 through 4, 5 through 19. High number of those are being impacted, as well as those that are 20 through 49. But in general, people that are young, people that are immune compromised, pregnant women are going to be at the highest risk for developing these infections. Those are the ones we're really, really concerned about. So what are some of the common causes? We kind of have an idea based on those headlines, the ones that we see most often that are going to cause problem. Raw milk, big driver is Campylobacter, like we said before. So this organism, it's found in the environment. It transfers by a fecal oral route. And say, so can happen during that milking time process. If animals aren't getting cleaned well, and say if you get entry of that organism into the tank, it can be from farmers with contaminated hands, things that are leading it into that milk tank that we're collecting. And Campylobacter can have some pretty serious complications. It's definitely one of those ones with severe outbreaks and can cause death, and what we call Guillain-Barré syndrome, which can interfere with muscle function and activity. So definitely one that causes a lot of trouble, and in poultry as well. The other common one is salmonella, and this is common across both raw milk and pasteurized milk. Salmonella gets to be a challenge because when it gets into the GI tract, it actually can go and invade into our cells and target other areas of the body. And so it doesn't just get into our GI tract, it invades and can hang out and also causes a lot of that foodborne illness that we see. So a big driver. The ones we probably hear the most about are that E. coli, the 0157 or S-Tex. Those are Shiga toxin producing E. coli. So when they grow inside our body, they release a toxin that activates our immune system, and it just makes it go crazy. So with COVID right now, you hear about that cytokine storm. That's exactly what's happening with E. coli, and it's just too much for the body to handle too quickly. And so you have an overactive immune response that is causing part of that problem as a result of that toxin. And the one that's probably just as troubling, and I think this was at about 4%, is brucella. Brucella does come from cattle, and for the most part, it's been wiped out, but in areas where we're just starting to see more evidence of it, and it can cause, it's brucella abortus, and so it can cause a termination of pregnancy in women. And so it's a definite issue that's out there. Listeria can cause similar problems with pregnancy. I say it can, illness and abortion. So these are some really impactful organisms that can cause major complications and death. And that's why we worry about them so much, is because of that risk. The big difference for pasteurized milk is norovirus. So how many people have taken a cruise? Anybody out there taken a cruise before? On one of those cruises that had the flu and developed norovirus, this seems to be one of those viruses that when it gets into the cruise ships, it just rapidly goes through the whole ship. And so pasteurized, this seems to be more of a processing issue when you start talking norovirus and the sources there. And so that seems to be the biggest difference, is the type of organism that's causing the dominant infections that are out there. All right, so I want to show these graphics as I go through kind of how I see them in terms of who's the winner, and say in the battle. And so for raw milk, in terms of the risk and the complications that come from that risk of foodborne illness, that is definitely a negative for raw milk and a bonus for pasteurized based milk. You just don't have that same impact. And so it's a very real risk that's out there. So the next phase we're going to move into is, and I want you to think about these aspects when we're discussing. So we're going to focus on health aspects. I want you to think about the composition or the function of those compounds that are in the milk. So some of those proteins, fats, vitamins, and minerals, how do they function in raw milk versus pasteurized? The other part we're going to get into is that influence on gut health and nutrient availability. And so, I don't know all right. Influence on gut health and nutrient availability. So how does that shift with raw milk versus pasteurized? And that's just the localized aspect. How does that relate to overall health of the person? And so those are kind of the three key things to think about as we go through the next several slides. I just want to pull that off to the side, just in case. All right. So are there negative consequences of pasteurization on nutritional quality? This is one of those common questions that are out there because pasteurization is a heat-based process. And as a consequence, the Part of the reason it works is because it changes the structure and functionality of some proteins, not all, but definitely some. So how does pasteurization influence the bioavailability and activity of some of the proteins and things that we think about relative to milk? So denaturation is when those proteins are going to lose their shape. And so when they lose their shape, they're not as functional and can't do what they need to do. Or it may change the ability of it to be broken down or used once we ingest it. And so it can cause some changes there. Stability, it may allow it to break down more quickly or slowly, depending upon how it modifies that protein and the bonds that it has. The ability to bind receptor or partner proteins that are in place, and then ultra digestion in that GI tract. So those are some of the things we're going to kind of think through as part of it. So we look at pasteurization and we look at kind of those key big picture nutrients, vitamins and minerals, calcium, and proteins. There's about a 10% difference when we look at that gross level. Thiamine, vitamin B12, vitamin C, very limited difference between raw milk and pasteurized milk. Not enough that it's going to have an impact on that nutritional quality. Same would be for calcium, which becomes about 6% insoluble or not able to be easily absorbed. Protein, you get about a 1% coagulation rate and changes its availability, and then a slight breakdown in those fat globules, but nothing that's really interfering with the nutritional quality of that milk when we look at it at a gross level. So I give those both wins. I say raw milk and pasteurized milk. I think they're both good. But the one thing I think we need to investigate a bit more is there's a lot of proteins in milk. So Dr. Tim Reinhardt and colleagues up in Iowa, they went in and looked to see how many different proteins does cow's milk have, and there are over 3,000 of them. Some are soluble, some are part of cell membrane proteins, some are part of milk fat globule proteins, but 3,000, almost. It's like 2971 or something like that, but a lot of milk proteins. So I'm curious about what about those proteins that we haven't looked at yet? How are those impacted? And there's definitely more research looking at this aspect now, because we're getting into what are some bioactives in milk that we can isolate, better understand, use to our advantage. And so this was some group work done over in, I believe it was in Italy. And they just took raw milk, pasteurized milk, and looked at the ability of, or looked at the types of peptides, so small pieces of protein, and their potential for being immunomodulating, so they can change your immune function. Doesn't say good or bad, but it just changes it. ACE inhibitors, antioxidants, so decreasing those, say, we all hear about antioxidants and how, say, inflammation is more oxidative. Antioxidants would help lower that inflammation potential. Antibacterial, so being able to kill microbes, anti-cancer, and then opioid agonists, or those feel-good molecules in our brain, say that are activated. And so looking at the differences, raw milk tends to have significantly more immunomodulatory bioactive peptides, saying this is in goat cheese, versus the pasteurized product. And so a difference of about 5,500 to about 6,200. So about 700 different ones. Those ACE inhibitors, and say considerably bigger difference between raw milk and pasteurized. And these are the two biggest differences overall. And so going in and identifying what are those compounds, how high are they in milk, how are they impacted, can we use them to our advantage in helping to treat individuals? Problem is, what we know right now, just we're still learning in the process, because this work was done not long ago in 2015. And so that literature is growing, we're learning more and more, but it's still a research in progress. Pretty similar in terms of antioxidative or anti-inflammatory potential, antibacterial similar, cancer similar. Pasteurized milk has a little bit more on the opioid agonist. An agonist means that it interferes with the ability of those opioids to work. So the opioids, the feel good, agonist is the block. So this is blocking our happy feel good component. So those are groups of proteins. There's another one that I'm also curious about. So in the immune world, there's lots of proteins. Some are going to cause more inflammation. Some are going to cause allergies. Some are going to cause an acute reaction to that infection that we need to have in order to fight it off. And some are going to allow tolerance so that it can be protective in our bodies so we don't react. One of those proteins is called TGF-beta, and it helps prevent allergy development. And so there's some work, and I believe this is in Italy as well, and I can't remember where this group is from, but when we look at raw milk, TGF-beta, it is a little more than double than what we see after milk's been boiled, pasteurized, or even filtered. So this is being pulled out of the system. Is that going to help? I don't know. Because the other thing we need to keep in mind is, yes, it has more TGF-beta, but it still has to go through that digestion process. And would it have any impact once it gets into my stomach and small intestines and large intestines and broken down? So that's probably where the biggest question is it biologically relevant as part of the process? And so that's something I'm curious about and think we can investigate to see if raw milk has that beneficial aspect in terms of allergy development. Oh, I got the words down, so beat me to the punch. Now this one is known. So speaking of allergies, there are definitely people out there that have milk allergies. And this is where that debate of, and I've heard anecdotal stories of going out and saying, okay, we had store-bought milk, we had gastrointestinal issues, let's say we had skin breakouts, things like that. This could be due to a milk-based allergy that's in place. So they took raw milk, they took pasteurized milk in the red, looked at this protein called IgE. So when we talk about antibodies, we can break them down into subtypes. IgE is that subtype that is tied to allergies. So if you have allergies to bee bites, let's say I'm allergic to dust and mold and seems like everything else, this is what I have in excess of. If you go get allergy tested, this is what's going to pop up, is this IgE antibody and cause those little welts we saw with, if you've ever had an allergy test, that's when you get those little red itchy welts that are in place. So they looked at the concentration of IgE. These are two main proteins that are present in milk. So lactoglobulin is about 10 to 15% of all milk protein. Lactoalbumin's a little bit less. When we look at the development of antibodies against milk protein, we find significantly higher. It went from under 10 to nearly 100, so almost a 10-fold increase in antibody levels that can lead to that allergic reaction. And so this is one of those circumstances where there would be less of a reaction against raw milk than to the, say, to the pasteurized part of the product. Lactalbumin was similar, just not quite as strong in antibody. And it might be just because we have more lactoglobulin there. There is a concentration-based part to this. Pasteurization, at least in this study, did not alter the symptoms of lactase deficiency. And so kind of overcoming that, say, that lactose intolerance type of question. So they looked at raw milk, these dark bars, pasteurized milk, soy milk. And so the question is, does pasteurizing interfere with that ability to digest lactose? And they did this, they basically did a crossover study. So it's the same people. They drank either raw milk or pasteurized milk, had a gap in between, swapped them, and then drank the other. And so it was within the same person to see if they had differences in symptoms between the raw versus pasteurized. And in general, in terms of getting gassy, which my brother is lactose intolerant. Poor boy can't even have milk chocolate. Just a little upsetting. But in terms of flatulence, diarrhea, those noisy gurgling noises from your GI tract, and cramping were all similar. So it doesn't seem like pasteurization is going to have a large impact on that lactase deficiency aspect. So in the end, I will say there are some pros and cons. Just beware that there's still a lot more research needed when we start getting into those individual proteins and how things are impacted across the line. The one that has the most evidence for is those antibodies against the whey proteins, especially the lactoglobulin. That one's a little more, let's say, recognized in terms of the issues. So if you have that allergy development, you may benefit more from raw milk than pasteurized milk. Always weighing in mind the risk of foodborne illness in place. So I'm gonna switch gears just a little bit. So microbiome, we all hear about microbiome now. It is basically just a microbe community that occupies a given space. The mammary gland, the milk, has its own microbiome. Those organisms that are present in milk that kind of maintain the environment and prevent major infections from occurring. Same thing in our GI tract. And in fact, the bacteria that are and the microbes that are in our GI tract way outnumber the cells in our body that are in place. So those are our microbiomes, and we can influence those by what we eat, how we're stressed, a lot of different, ways we can influence those niches. I know we hear a lot about microbiomes, but I wanted to bring in an immune perspective, which is going to have relevance with some of the other topics. So what happens when we just totally wipe it out? We go into our GI tract and we get rid of all the microbes that are there. That is what they did with these isolator systems. So they would actually take mice, they're called germ-free mice, and they go into these little germ-free isolators, and they don't see access to any outside microbes that are in place. So I have some pictures down here just to kind of showcase, not necessarily here, but what that interaction looks like. So this, all these different colors, the blues and the greens and the oranges and the reds, these are all different types of microbes that can be found in that mouse GI tract that comes from here. If we change and expose them, the dynamic makeup of this group would change. And so we can do that through a lot of different things. It can be taking antibiotics. It could be whether you were born by C-section or natural delivery. For a calf, it could be whether it nursed or not. Same for humans. I say whether they say nursed and had breast milk versus not. Can completely change the dynamic nature of this microbiome. And this, let's say this is bacteria over here, the little red dots. This green, these are goblet cells that release mucus. So this is your intestinal tract overall. This is the internal side, the tube where all the bacteria are, and this is your body side. Cool part is, I say this green, these are goblet cells that release mucus that's antibacterial, kind of similar to what would be in our nose, and it keeps the bacteria away from getting in and interacting with our cells that are in the intestinal tract. So that's one of the ways we keep things separated. And this actually is also part of our GI tract. These are areas called Peyer's patches, and it's a really immune cell rich region. Think lymph nodes, similar to lymph nodes, but they're actually directly in your GI tract. And so when we have, and so when we get into this, coming back to kind of bring it back to relevance, cool part is whenever we have this shifts and we lack the differences, immune cells in the intestine are smaller and fewer in number. When that happens, you get shifts towards allergy development rather than tolerance. And this is relevant when we start talking about what you're exposed to and when you're exposed to it as part of the process. So hopefully I got some of you excited about immune function and GI tracts. So thinking about diversity in your intestinal tract and immune development. And this is a perfect example of those differences. Someone that's on the farm, young kid, exposed all the time to what those cows are exposed to. So this is me. I say a lot of manure, because I know I ran around in my bare feet. I had brothers, and so we'd roll around in the mud and the muck and have a good time. And I did grow up on raw milk, and I was exposed to everything those cows were exposed to. So when my GI tract developed and my immune systems developed, I was able to develop tolerance against a lot of these organisms as a respect to that. Same times that the cows were. Then we have a different scenario where you are now out in, let's say out in town. Let's say, I wish I had an ice cream man when I was younger, but they're not exposed to that same environment, not exposed to that say little manure-laden environment that can be the dairy farm, where you are exposed to those organisms on a regular basis. Their immune system that develops can be different, and most likely is different from somebody that grows up on the farm. It's in place. And so this is where I want to think about, if you're drinking raw milk versus pasteurized milk, how does that relate to those organisms that are in raw milk and your ability to fight off infections that's in place? So just keeping in mind, complex environment is what those cows are exposed to. And that's going to influence that milk microbiome and what's present in the milk from those animals that's in place. So looking at the microorganisms, and I'm not going to say worry about this so much, it's just to show that there are lots of different types of organisms that are present in the milk naturally. And if an animal's sick, if it changes their diet, these can have shifts in what's there. And when we do pasteurization, it's going to kill 90 to 90%, 99%, depending upon which methods you use. This is one of the questions that I'm curious about, that I think there's potential links there. Raw milk, when we look at the type of organisms, they tend to have more of these firmicutes, or less firmicutes than what the pasteurized milk does. More proteobacteria, less proteobacteria. How does that relate to subsequent development of that GI tract and risk of infection that goes in place? The one that I know has some ties is the firmicutes. Pasteurization increases that group. Totally different research, not linked, have no idea if this would be true, but if those bacteria from the milk are in the gut microbiota and alive, would that relate to changes in obesity and allergy development, which typically gut microbiota share? When we have more of these in our GI tracts, there tends to be the direction towards obesity and allergy. So where I think research needs to go is investigating this link between raw and pasteurized milk and our ability to take that in. So bottom line, more research is needed, without a doubt. I think there's a lot of cool things that we can do, and that research is ongoing, and to see where it goes. All right, just to reiterate, our GI tract, cows, diet, health status, stress, all of that influences the makeup within those tracts and those systems. So if you were exposed to what the cows are, you should have less of an allergy development, less of a strong reaction. This was a study from Lancet back in 2001, just looking at that investigation. The blue bars are no exposure. The red bars are farm milk. We'll just do this quick comparison. No exposure to farm milk. And you see this reduction in the percent of children that are developing allergies. Let's say whether it's asthma, hay fever, or other allergies that are in place. And so there is, let me go over here real quick. There is that potential link. What we don't know, because it's just farm life and they just say milk, were they actually drinking pasteurized milk or raw milk? Because you can't pasteurize it at home on the farm. And so there is, I know it's been used a lot for saying raw milk benefits, but I think we have to go back and just say it's more farm life and milk overall, not the raw milk that's in place. And so that's one of those distinctions that we need to make on that one. So caution, we develop tolerance to organisms we see on a regular basis. I have less concerns about people that are on the farm and drinking raw milk than people that are not from on the farm and drinking raw milk, just because of those risks that are there and because of that foodborne illness. In general, more research. I'm always up for more research. Dig in. All right, I know I got a few minutes. So raw milk. Raw milk cannot be sold across state lines. Bottom line. And so, and that's just part of the pasteurized milk ordinance. I know there's some efforts to change that law that are in place right now. So the variations that are in place, you can sell it in retail stores which those are the ones in the green. And you can actually, and there are regulations tied to that. You can sell cow shares. You can sell directly off the farm. You can sell at a farmer's market. So there's different ones depending upon where you're at. Questions, since I'm having a hard time navigating. Blew y'all away with too much immunology?
Well, we definitely got our brain stretched, which is awesome. We do have a question in the Q&A box. We would love to have more from y'all in the chat. Is there a geographic profile of where raw milk complications usually occur?
Say that again.
So is there like a general area of the country where we tend to see more outbreaks, is what I think the question is asking.
Actually, yes. There tends to be more outbreaks where raw milk is legalized. And they're linking, and that's been part of the links that are there. So we've had almost a doubling in outbreaks over the last, say, going from 2010 to 2012 versus the 3 prior years from that. So that's almost doubled, and almost 80% of those were tied to areas that had raw milk easily available and accessible. So the more accessible it is, the more outbreaks there are. And I think that's the big concern that's out there now, is if we continue to legalize, those aspects will have more and more outbreaks and those risk of complications that are out there. And to add to that, the areas that sell raw milk and the neighboring states that you can just kind of cross the border really quick, they also tend to have higher outbreaks in those adjoining areas. So not a specific region, but definitely anywhere that's tied to raw milk sales. Long-winded question I answer.
Any other questions to throw in on the chat or in the Q&A? So me just being nosy, on one of your very first slides, you were talking about the populations of people who have access to pasteurized milk and pasteurized dairy products, and the populations of people who were drinking raw milk or consuming raw dairy products. So could you give us like an idea of what kind of population? Are we thinking about something that's even remotely similar? Or are we thinking something like several million people, couple thousand? Like what's our bracket look like for those?
So in terms of the number of people, so from what I've been able to gather, the people that are drinking and consuming raw products are about 2% of the total population versus the remaining, and that's relative to milk consumption. About 2% are going to be drinking the raw milk products or consuming raw milk cheeses, versus the remaining 98%, which is going to be the pasteurized product. So it's I don't have numbers, but it's definitely a different group.
Ooh, that's an exciting question.
And
if you grew up on a farm and then leave, how long does that natural or that acquired immunity last? It's a really cool question.
It is, and I don't think there's a good, easy answer. I am going to speak from experience. So there's a lot of other factors that go into it. They do believe they last for definitely through your younger years of, say, growth and development. But anecdotally, I don't get foodborne illnesses. I don't get the flu. But that could be genetic. Mm-hmm. That could be just something I just naturally don't get. It has nothing to do with my consumption of raw milk. But I can't prove it one way or the other. So it's a great question. I don't think there's a good answer, because those groups they followed in 2001, I don't believe there was a follow-up for them later in life. And I'm not aware of any studies that have looked at it relative to later in life. It's just those teenage years, roughly. So it's a great question. We probably need to go check it out. and do some follow-ups. And people are, I ran into some people in my neighborhood that want raw milk, and that's their preference. They know the risks, they understand the risks, they're willing to assume those risks. So that would be my question for you guys. What is it worth the risk?
Coming from the other side of the equation, right? I did not grow up on a dairy farm. I am mostly a city kid, born and bred, and I do not have that same innate gut that Gina has. So even if I know the farmer really well, I know that they are really clean, and I know that they do a great job, I am very leery about drinking raw milk. And it is nothing against the farmer. It's nothing against their management. It's just that my body is not with those same bacteria all of the time. So my body is used to weird things from parts of Texas, New Mexico, and Louisiana, now Kentucky and Tennessee. So my gut's been exposed to a lot. Way too much spicy food is probably what you're getting from this, but I haven't been around those same bacteria that are going to be endemic to that environment. Even though I'm around cattle a lot, I'm around dairies a lot, I still have concerns about what are the risks to myself if I drink something that hasn't been pasteurized. And that's just because y'all probably saw it on one of Gina's slides earlier, and we talked about it a lot in our previous discussions, that pasteurization kills 90 to 99% of bacteria. It does a really good job of killing any bacteria that could potentially hurt us, potentially hurt any of our kids, potentially hurt any of our parents. And that's why pasteurization has been the standard for so long.
Yeah, and there is a question, can pathogens be inherent and be released by the cow in the milk? Most definitely. So they get the same infections we do. They can have infection with salmonella. Campylobacter can cause issues in dairy cows as well. E. coli is there naturally, and they don't seem to blink an eye at it. So that one's is not a big culprit for them, but those can be shed in the milk. And brucella is another one, shed in the milk. And if you consume it, you're going to be exposed. So the risk is, did you have a bad day? Did the cow have a bad day?
Mm-hmm.
Did you leave it sit out too long? And so those bacteria had the opportunity to grow even more. Mm-hmm. And that's where the real risk comes in, is that you just don't know. And it's difficult to minimize that risk, because milk is probably about 3 to 4 days max in the fridge when it's raw. And so just the ability of that bacteria to take over is much higher than pasteurized, where we've pre-killed a lot of it. And like Liz, though, I say I would hesitate now to go drink raw milk. Knowing what I know now, I would hesitate. It's a fine balance, because I can see both sides. Mm-hmm. This is where I get torn. I can see both sides of the equation, and I can see it, but I would hesitate now. I would have to know a lot about the farm. I would need to know what my risk level is. So if it's a dirty farm, my risks go up. If it's a clean farm, there's still a risk, but it's not as bad as the dirty farm. Mm-hmm. But the risk is still there.
Yeah. So you have a question about the farm to consumer website, and says, is it showing raw milk for dairy only, or does it include milk from, say, goats as well? So I believe
on the site.
Depends on the site, yeah.
Or depends on the state, actually. So some states will have goats written in, some don't. And I think that website, one of them shares goat information. I know one of them shares goat information. I can't remember which one it was. But they link to what the rules and regs are for those individual states, and you just got to look it up.
But one thing that I want to remind everybody about before we hop off of here today in a few minutes is that raw milk sales, farm to consumer, are not legal in the state of Tennessee. So raw milk sales are not allowed to happen. So there is herd share, where you can own part of an animal, or there's really just herd share, because the other way is a workaround and is also not legal for people to consume. And the goal of today is not to direct you one way or the other, and I really hope that you don't take that away from this meeting. The goal of today is to talk about why we have the systems that we have, what are some of the potential risks with each system, what are some of the potential benefits with each system, and hopefully to shed some light on why our standard is pasteurized milk and pasteurized dairy products. Because another thing that we haven't talked about a whole lot is how far around the country milk can spread from a single farm, right? So milk from right down the road could end up in my neighborhood store. It could end up in Georgia. It could end up in Florida, in North Carolina, in Kentucky, in Virginia. So if I'm taking milk from one farm here, I really can't expect it to be the same as far as the immune function of everybody in those surrounding states. So that's another really big reason why we think about pasteurization being the norm as far as what we have, and probably another reason why we have a lot of restrictions on going outside of the state lines with selling some of those raw products in states where that is legal.
Yep. And I will say the cleaner, the less bacteria and the less somatic cells that are in your milk. So less, let's say less overall, the longer it keeps.
Mm-hmm.
So it is an indication of potential quality level.
I'm not seeing a whole lot of movement in the chat or in the Q&A, so I'll give y'all a few more minutes. Anything else we want to talk about, discuss?
Well, hopefully I didn't blow your minds too bad with the immunology. I just kind of enjoy it. Obviously.
No, some of those pictures were amazing. Like, oh, what is that? So,
even if raw milk is legal to be sold intrastate under federal law, it is not legal to be sold interstate. Exactly right. It is not allowed to cross state lines, which is why every state has its own set of guidelines because they got to make their own rules within the state. Mm-hmm. Okay, I can tell I've been talking too much today.
Time for some water or some milk.
If I had milk, I would do that. I had some eggnog too, which was excellent.
Oh, I bet that was good.
Can we test the raw milk prior to sale? Yes.
But
we can, but there's a time delay. And that's a big part of it. And so there's difference. Basically, there's a time delay whenever you test it. So if you culture it, it's going to take at least 24 hours before you start to see any growth. There are some systems out there that can detect quicker, but they're not validated for raw milk situations. They're only validated on some other products. And so right now there's nothing there really to allow us to do a quick test for the different organisms we need to check for. And that is when they do have the raw milk sales, like in Pennsylvania, they do checks, but I don't think they do them enough. I think it's once a month, which is a little insane. So not frequent enough for me.
That's one of the things where if any of y'all of our dairy farmers who've ever sent samples into the Tennessee Quality Milk Lab or any other animal-based lab, you'll see a little disclaimer on the bottom that says, this does not reflect pathogens that are for foodborne illness and does not mean that this is safe for human consumption. And that's because with our food labs, we're looking more for things like we talked about 2 months ago. It's been a while. Remember back a bit when we were looking for bacteria that cause mastitis infections. So just because it causes a mastitis infection doesn't necessarily mean that it's going to cause a foodborne illness. And just because it causes a foodborne illness doesn't necessarily mean it's going to cause a mastitis infection. So we can't kind of treat them all with a one-size-fits-all mentality, which is where we get into the time delay and specialized equipment and all that fun stuff.
Yeah. Thank you, everybody. Yes, I had fun. If you want to talk more, feel free to get into. Oh, you know what? I didn't include the last slide where you need your stuff.
Oh yeah, hold on. I'll share it before y'all jump off. Chat too.
I say I had that in here actually, and the take home. So you know what? I just
Let me see
didn't
if I
finish my
can find
presentation.
mine. So if y'all are not newbies to this, you know that I'm going to ask you to take a survey at the end of this presentation to tell us what you liked, what you didn't, and how it went. And I'm going to add the HTTPS in front of that because when you type it in, it doesn't work. So for any of y'all who attended today and anybody who would like Master Dairy credit, and I realize we're dropping off quickly now, please go to the attached link. It's https://tiny.utk.edu/C2C_ and the word survey. And let us know that you were here, and let us know what you liked, what you loved, and what you really loved, because obviously you didn't dislike anything. So thank you, everyone. We appreciated you being here.